is KHADER Electronics made easy. So a couple of months back I was on a vacation, and while going on vacation for, I think if I go for a vacation for more than 3 or 4 days, then the main concern for me is my plants and my aquarium, because my plants might die if there's no watering, and the fishes might starve to death. So for the aquarium, I had a plan, because there's holiday food available and I can just drop few traps into the aquarium and that will last for almost like a week. But for plants, I cannot give my plants to my neighbors, because I have a jasmine creeper which almost covered half of my balcony, and I cannot remove it and give it to the neighbors, and it might die is one, and I don't have such friendly neighbors to give it to them and ask them to water. This is the second problem I see. So last time when I went on a vacation a couple of months back, what I did was I made a small setup which had a small water pump kept in a bucket of water, and this pump was operated based on a sound activated device, a sound activated module. And so where do you get sound from? So I kept a spare mobile near to the sound module, so whenever I call to this mobile, it would start ringing, and it would trigger the sound module and eventually start switch on the pump. And the pipe of the pump was connected to fixed near to all the plants, so that it will have enough water. So I designed this on the last day, because I haven't planned it properly, so I couldn't design it before with a reliable device. So on the last day I almost spent like 3 to 4 hours, and I designed this, I fixed it, and frankly speaking it did work well for 2 to 3 days. And I was on vacation for almost like 4.5 days, and to my knowledge it might have watered for almost like 2 days. So the one of the problems I saw was the sound activated module doesn't work as expected, so I have to call 2 to 3 times a day in different timings, and I hope that at least it water at least little. So as I said, on the 5th day which I came back, and when I saw plants weren't in such a good condition. I won't say that it didn't water at all, but I guess it didn't water for the last 2 days alone, and it did work properly for the first 2-3 days. And so once I came back, I started researching more, what kind of alternatives can I place, and what kind of devices can I use like this, for the next time I go on a vacation, maybe a month or later, then I can have some backup setup, so that it'll water the plants on time, and whenever I want I can water the plants. I would know that okay, it's watering the plants, because last setup I'm not sure if it's watering the plants. It just blindly call 2 to 3 times, and it might water, it might not water. I'm not sure what will happen. So from last month or so I have been researching on this, and I found few of the modules like NodeMCU module, which is a very reliable and I would say great piece of electronics, because it's very simple to design, program it, and very easy to operate, and there's Blink app available which you can use. So in this video I'm going to show you how I used a NodeMCU module and Blink app to design a small watering system, which I can water from anywhere in the world actually. So I'll just set up the pump in the bucket of water or a tub of water, or wherever I can even set up a valve. So I'll put that, I'll set it up for all the plants, and I'll leave for the vacation. And whenever I want to water the plants, I can just activate it from my mobile app. And the main advantage is I'll know if it is watering the plants. So that is a sign that okay, I'm sure that okay, it's watering the plants. I'll be I'll feel happy that okay, it's watering the plants. So without any delay, let's see how it's done.
This is a NodeMCU module, and to control it we would need the Blink app, and also we would need the authentication token for this one from the Blink app. Once the app is downloaded, we can go ahead and create a new project. First I'll start by selecting the board, which is a NodeMCU. Other options are quite simple, you can go ahead and select them accordingly. And once you create it, an authentication token will be sent to your email address. This is what we need to program the board. Next it will take you back to your project. Here you can add all kinds of buttons just by clicking on the screen, and you can drag them to whichever position you want. Here I have added a button and a level indicator. I'll show you next how we can use the level indicator to identify if watering is done or not. So here I already have the app ready, and if you go inside and check, the button is mapped to the D3 pin while the level indicator is mapped to A0. And as you can see, it already shows if the board is online or offline. As you can see, the board is not on here, so it's offline. Next, I'll go inside the button settings and I'll select D3 pin for the button, or whichever pin you want. I can also select the color of the button here. I'm selecting yellow, and pin as D3 or D2, whichever you want. And these pins directly represent the pins on the board, so you can select whichever pin you need it. Next, I'll select it as switch. If it's a button, it will be a push button. Once done, I can just save this and come out. And here, if you can see, I have named it as watering, so instead of on and off. Next, going to the level indicator is mapped to the A0 pin, which is the analog 0 pin, and here this will indicate the level of water. And I've selected multicolor here, and the time and everything, the other settings you can select based on whatever you need. Now the app is ready. Next, we need to program the NodeMCU. For that, we'll connect the NodeMCU to the laptop using a USB. Then we'll open the Arduino programmer. Here we need to download the Blink library and also the board for NodeMCU. First, we'll open the libraries, and here we'll search for Blink. Once you get Blink library, you can install it. As you can see, I have already installed it here. Next, we need to install the board. So here I'll go to board managers and search for NodeMCU. Once you get NodeMCU board manager, you can install that. After installing, we'll go to examples and we'll open a sample sketch from Blink library. Inside Blink library, we'll go to the Wi-Fi modules, and here we'll select NodeMCU. Here you have to change 3 places. One is the authentication token, which we have got through mail from the app. Next, we have to add the Wi-Fi credentials. As you can see, the SSID says the username of the Wi-Fi connection. Next, we have to add the password in the password field. Once done, you can compile the program and then write it to the board. This ends the instructions to program the NodeMCU. Next, I connected an LED from D3 pin to the ground. This will help us test if the board is working properly. I gave power to the board from a power bank, and then I took the mobile. As you can see, initially the LEDs light up. Now I'll switch it on, and as you can see, it switches on when I click on the button. Next, I'll try switching it off again. It switches off, so it's working as we expected it. Next, I connected a wire from A0 pin to D3 pin, and as you can see, when I switch it on, the level indicator increases, so it's working as expected. Next, to detect the level of watering done to the plants, I have designed a small circuit here. So say for example, if you have 4 plants, then I have 4 levels here, each with A1, A2 and A3 and A4 are the pins which will go into the pots. So one wire from the positive terminal here, which is the D3 pin from the board, and other wire will go from this A1, A2, A3. And all the resistors in the circuit I have selected as 10K, and these will act as the voltage divider circuit. So based on whichever transistor is shorted and connected, that resistor will be connected in series with the bottom resistor, and it will act as a voltage divider. The voltage here at B pin will be connected to the analog pin of the board, A0 here. For example, consider this voltage divider here consisting of two 1 kilo ohm resistor, and the voltage is considered a half. So the voltage across the bottom resistor will be 2.5 volts, which is half of the actual voltage given. Similarly, if you increase the bottom resistor or the top resistor, the voltage here will vary. The same principle is used in the top circuit as well. From this circuit, one wire, either A1, A2, A3 or A4, and the other wire from the D3 pin will be going into the pot. We'll be placing it a little higher than the soil so that when water starts falling into the plant pot, it will start filling up the pot with water, and once the water touches these two pins, it will indicate in the board saying that water is falling in. I have built the circuit on breadboard like this and tested it with few connections. Next, to drive a relay. So this relay will be powering the pump which will be watering the plants, and this relay will be driven from this transistor. I have used a BD139 NPN transistor here, and this relay will be connected at the collector of this transistor. I have designed a simple circuit for driving this relay with a BD139 transistor, and as you can see, the D3 pin is connected to the base of this transistor and the relay is connected at the collector of this transistor while the emitter is grounded. So let's build this circuit on a PCB now directly. I have connected a series resistor across the base of this transistor which is driving this relay. This is to avoid loading problems. Now the circuit's ready. I'll be connecting few long wires across these transistors, and I've also connected an LED here just to indicate if the relay is on or off. Next, I'll be connecting a terminal here just to connect the pump which is watering the plants here to the relay. I have also connected a USB wire here just to power this circuit. For the pump, I am using this air cooler water pump which is of very low power, and as you can see, I have already attached the pipe to it, and this one comes out very easily. I have used this one because as you can see, it's of very less power, and this is very easy available in any local hardware store, and it is quite cheap. I have attached a 2-pin plug to the other end of the wire of this water pump, and as you can see, I have a stripped wire in between and disconnected it, and these two pieces will be going into these two terminals on the PCB. And the circuit is completely ready. Now I'm using this plastic box just as a cabinet to this circuit, just to protect it from the water that's splashing, and nothing fancy. It's just just a temporary one. Probably if I get a better cabinet for this circuit, then I'll replace it. Initially I forgot to solder these wires which will detect the level of water in the pot. So now I have soldered two wires of certain length, probably a little more than 1 meter, to two of the transistors. I'm using only two here because I just want to detect if the water is falling in the first pot and the last pot, so that intermediate pots we can assume that they are filled. So I stripped the ends of the other end of these two wires. These have a length of almost like close to 1 meter, so that I can place it at some distance. As you can see, this is the test setup I have done now just to show you how this circuit is going to work. And here I have connected this circuit to the power bank here, which is already switched on, and the socket of the pump is already connected to the mains supply, and the pump is in a bucket of water. I have already taken half of the bucket just to demonstrate how it's going to work. The other end of this pipe from the pump I'll be placing in the plants. And here the sensor wires, as you can see, there are two wires, but I'm using only one here just to show you. And I've connected this to a small plastic piece. This I'll just poke it into the soil of the pot, and this will be a little higher than the soil level, so that once the water starts falling and once the level rises and it touches the sensor, it will show you that it's full. And this is my jasmine plant. I'm going to demonstrate this circuit on this, I'll just poke the sensor into the soil now. I'll make sure there's at least half an inch of gap between the soil and this wires. I've placed the pipe from the pump here. I have put it little away from the sensor so that it doesn't water doesn't fall on the sensor directly, and switch it on. Next, I'll open the blink app, and here, as you can see, as soon as open, it's directly in this app, and the module is online now. Let's switch it on and see if it starts watering. As you can see, it's watering now. We'll notice if the water level rises, and it's shown in the app. As you can see, once the water touched the sensor, it started showing it on the screen, and once I switch it off, it will automatically turn off because there's no more power coming out of the D3 pin. So the circuit is working as expected, and what we can do is we can extend it to the all other plants as well. Probably I can put few more joints in the pipe and place it such that each piece will go into each plant. As you can see, I have spring onion plant here, I have mint plant, it's a huge, I have harvested most of it, and it's almost last stages of it. I have a small cactus plant here, it's a ball cactus. So that's all for today's video. If you like this video, you might like some of my other videos too. Please check them out at KHADER, and please subscribe to this channel if you want to view my upcoming videos, and press on the bell icon if you want to get a notification for my latest videos. So thank you, and I'll see you in my next video.